Alright, should be picking up. I'll give it a second or two to recover here. But as soon as this is picking up, this will be a whole lot easier than record and upload later. So, welcome everyone, especially those from 162L. So we're going to go over a few things today. One of the things I wanted to mention was the data analysis portion. So let's walk through that really quickly. The idea is you're going to have a physical dice roll. You're going to have the Tinkercad results. So you will have found, for most of my sections now, you will have found the updated version of the code. So what that will do once you're simulating this is it will do some flipping of some of the numbers. So we will have a bunch of different digits generated here. So each of them is going to give you should be a different distinct value. We're going to see if this is pseudo-random. You will see a couple instances. So this would be the upside down G described in the document. What you want to do is ignore occasionally this particular element. It's referred to as display element F commonly. What this is you're going to ignore this because this is actually the number 2. So back to the whole story about this is the project that Bob was working on, and Bob has since been fired for good reason. So this would be the number 6. This would be looking to see if I can get it to generate another number 3. There are a couple instances, so here we go. So this is the one that looks like it might be a 9. This is actually the number 3 because 9 is larger than 6. If you manage to roll 9 from a 6-sided die, I would be very impressed, as that's very difficult to do. So this would be the number 3, and that's what's being represented here. So you're going to be rolling this a bunch of different times, and you're going to be putting in information. So very rarely do I see actual 1s from the prototype, and that's part of what we're trying to look at and understand. So you gather up all of the data from the physical model and the Tinkercad. The Tinkercad might be similar to this physical prototype column. Anyway, the point is you're going to continue working on the analysis. So here's what it looks like. So once we've got all of our data copied in, what we're going to do is we're going to insert a chart, and in this case we're going to insert a scatter chart. 9 times out of 10 you want to insert a scatter chart, but you want to click a little bit away from the data set. So this is just some mechanics of operations of Excel. The reasoning why falls under the heading of trust me, I'm a doctor. So we'll get into some more of the detail later. So now you're going to right click and you're going to select data. And what this is going to do is you're going to be able to add in the data set that you're interested in. So we're going to go a column at a time. And so you're going to keep a label. You can even click the title. Once you've selected this, you're going to click the title of what you've been working with. And you're going to say, all right, I'm going to use that name. I'm going to use these as my X values. And say, so we're going to compare everything to the physical dice roll. That's going to be our X values. And this plot will make a little bit more sense after the fact. You always want to delete this in the Y column, otherwise it'll give you lots of headaches. So this first data set, actually, let's change it to Tinkercad. So we're going to say this is Tinkercad. We don't want both labels. We'll say this is Tinkercad and say OK. And then we're going to add another one. And this is going to be the physical prototype. So this is our actual circuit. Again, we want to keep the same X axis. So we want to keep the same reference point of comparison. And we want to include our y-axis now is going to be the physical prototype once we've got all 50 of our data points. And this is what we're looking to compare. So in this case, we're also going to delete our grids, and we have some sort of overlapping points and some not. And what I might do is I might recommend doing this as a bar graph as well. Because one of the things that you want to do is you're starting to kind of think through and analyzing data. Instead of telling you answers, I'm trying to make you think about this is the way that we actually do the analysis as an engineer. Again, this is about turning you into engineers, not about teaching you, here's what you do, follow this recipe, and out comes spaghetti from the other side of the process. That's not how engineering really works. So what we're trying to do is we're trying to find a way that we can graph this that makes sense to compare it. So there's a bunch of other graph types here. We'll look at really quickly just another type, and we'll do a 2D column graph, or in this case maybe we'll do a stacked column. And this one might be a better one to compare the parts of a whole data set. So another way that we can analyze the data, again, you're going to click select data. You're going to add in a data set, and you're going to call a series name. You're going to replace this with the series data and say, here's series 1. You're going to add in another one and say, here's series 2. This is the Tinkercad data. We want to be able to compare these back and forth, so I'm not going to tell you what these mean exactly, but one of the things that you're going to notice here is this is stacking the data sets together. So if it doesn't make sense to stack the data set, you're probably going to need another type. Again, I'm not giving you the answers as to what to do. What I'm trying to do is get you to start thinking through how that works, because obviously none of the dice rolls are 12, 16, 32 from a single die, right? So instead, this isn't maybe necessarily the best kind of graph, but you want to play around with some of the different options in terms of inserting a graph and see what kind might be the best. So you need something that you can do a really good comparison back and forth to go into your report, because at the end of the day, what you're trying to do is you're trying to satisfy the requirements that have been handed down from ultimately your boss. And that means you're going to have to think of ways that you can maybe compare a data set and make it meaningful and be able to add a lot more value to the discussion that you're having. And what that's going to do is give your boss the information that he needs to make the decisions in all of the many meetings that he's going to attend. So you can see here, for example, I've got a couple data sets side by side, and what we're trying to evaluate is a way that we can graph things to make it make sense and be able to make a case for, does this behave the same? Is this consistent, or is this inconsistent? So there's some other fun and exciting things that you guys can do to be able to analyze lots of different data sets. So we'll spend a